皆さん、こんにちは。私の講義へようこそ。聞いてくれて誠にありがとうございます。ずっと日本語で喋るのはちょっと難しすぎるので、今からドイツ語で続きます。Also mache ich auf Deutsch weiter. Ich glaube, das verstehen ein bisschen mehr Leute hier im Raum. Vielleicht aber noch nicht alle und auf Englisch ist es vielleicht noch ein bisschen besser. Yes, welcome to this talk again. I will continue in English and I will tell you a little bit about this tool that I have built and how it works. We start with introducing a bit this AI that I was using, the Whisper AI. Then I'll tell you how I use it to generate these subtitles that you just saw. And lastly, we'll go a little bit about how to use asynchronous programming in Python, whether to use threading or multiprocessing, and what are the differences between that. So the AI I was using is called Whisper AI. It is by OpenAI. It was released last September, which is between the release of Stable Diffusion and ChatGPT. So which is, I think, a reason why this AI has been a bit overlooked since then. I think it is very useful, and maybe you saw why just now. It's actually completely open source, unlike ChatGPT. You can see the code on GitHub, and the weights are on Hugging Face, so you can use it on any computer that you have, which can run it. Let's continue with this overwhelming slide. Don't worry, we won't go through everything, but this is basically all the details that there are for Whisper. It's also from the OpenAI paper, and let's just start with the training for the AI, what they've done. How did they achieve what you just saw? So they trained on mostly 3 different kinds of data. They trained on English sound with English subtitles. They trained on non-English sound with non-English subtitles, and also some on, for example, German audio with English subtitles. So the translation was also in the training data. They used a lot of different kinds of audio, I think mostly from YouTube, but also probably other sources, which means that this model is very, very robust. And it doesn't really need any fine-tuning. So what I just showed was the pure model that you can download it. And maybe you noticed that I didn't even have to tell it what language I was speaking. I didn't switch anything. I just spoke in different languages. And it just realized what's going on and translated all of it to English, because that's what I told it to do. I could have also told it to write down what I'm saying in the same language, but that's not quite as useful, maybe. Back to this overview. So on the top right, we have the architecture of the model, which we're going to look at next. And if you have been following AI news in the last year, you might recognize this shape. It might be like this. It is actually the exact same architecture, pretty much, as transformers. So the same as ChatGPT. The T stands for transformer. So what we see. I'll just go through it a little bit in a little bit of detail. I'm not a super expert on that. But ChatGPT has inputs and outputs, and both are text, right? You put some text in, and it gives you the next piece of text. And the architecture is that there is something called attention, which means that to predict the next token, it looks at all of the tokens, or the context window of the tokens that it has, that it came before. But not all at the same level. The attention part means that some tokens relate to other tokens more specifically than others to others. So this is quite a very simple mathematics, actually, and a very genius concept, and it works really well. It just means that, for example, if you're talking about, if I start speaking Japanese, and it has like a keyword that is obviously Japanese, then that will spread to all the other words and say, hey, we're talking Japanese, for example. That's kind of how it works. And Whisper doesn't have text on the input side, but sound waves. But the output is exactly the same. It's also tokens of text. So Whisper learned to listen to sound, and it also learned the correct text output. So it tried to predict the next text token, just like ChatGPT, just the input was a little bit different. So now when I'm speaking, it listens to the sound, it tries to predict the next text token, and it's really basically the same thing as a text transformer. This is quite a nice parallel. The last part I'm not really going to explain. This is just about how the tokens work in Whisper exactly, which is not maybe extremely interesting. Instead, I'll show you another example of what I mean by robustness of the model. So I'm going to play this clip. It's the beginning of a song. And I want you to try to understand the lyrics.
Break it down, thinking of making a new sound, playing a different show every night in front of a new crowd that's new now. Chow seems to laugh is great now. See me lose focus as I sing to you loud, and I can't, no, I won't hush.
Who understood everything? 1, 2. 2 people. Maybe you are from Britain. Maybe you understand sign language. Or maybe you are Arens super fans, I don't know. But 2 people out of maybe 50. Of course, I also don't really understand everything. One of the first things I did was put this song into Whisper. So just the base Whisper that you can download, and that just the base version of it takes sound, basically an MP3, for example, works for a while, and then gives you all the text that's in the sound in this MP3. So let's see what Whisper heard. You can check the text is after these brackets. I'm going to play it again.
Break it down, thinking of making a new sound, playing a different show every night in front of a new crowd that's new now. Chow seems to laugh is great now. See me lose focus as I sing to you loud, and I can't, no, I won't hush.
It's not too bad, I think. Yeah. Well done, OpenAI. Yeah, and this text was not generated by the real Whisper, the largest model. There's one step down. They have a few different versions, and I used a medium one which runs on my own computer at home. So I have a gaming computer with like a graphics card from 3 years ago, and mainly just the one thing that's limiting is the graphics memory. So I have 8 gigabytes, and the real Whisper needs 11. So this is not even its final form. Yeah, another example of how good Whisper is. So many people tell me, Microsoft Teams has the same feature, right? Yes, it does. It does have the same feature. You can speak any language, and it will give you an English subtitle. So here's a little bit of I turned it on while we had a meeting at work. It says, yes, so it may be that she does not jump in that at all. The problem was, and then the relaxed, it was really because of this. Okay, very helpful. And at the same time, I was running my own, again on my medium-size graphics card, my own program, which is the same that I demoed at the beginning. And that says, so it could be that the sprint wasn't the problem. And then it was really because of these block things. So you kind of know, I mean, if you know we're in a retro, we're doing Scrum and everything, that makes sense. So that is a difference. But the biggest difference here is that the thing on the left, is running in the cloud, right? So, I mean, there's some more implications, but I'll get into it later. But the thing on the right is running locally on my machine. So it's really, really portable, and you can do a lot with it. So I think that's really fascinating, why I want to introduce Whisper to the world a bit more. So, let's talk about Whisper AI for subtitles. Basically, how I used Whisper, the program that just takes an MP3 and gives out text, and made this tool that you saw at the beginning, which transcribes and translates live while I'm speaking, which is not really the same thing. First of all, why did I do this? What was the challenge or the idea? So I used to work in a Munich-based company. This company was founded like over 20 years ago now, and used to only have German employees. Now they have expanded. They have hired people all over Germany and also all over the EU. Some are even working in Australia now. So 90% of the employees are still German and maybe don't speak perfect English. They usually do speak very good English, but maybe not perfect. Maybe it's nicer for them to speak and hear something in German. And 5% don't understand German at all. So this is kind of a conflict. And there was a weekly meeting that gives updates about the company. And it used to be only in German, obviously. And it continued to be in German for a while there were non-German speakers in the company. So the solution was to have this distilled version of that meeting just after that in English for the English colleagues, which is a workable solution. But what I really wanted is that everybody in the company can come together again into this big meeting where we have important announcements, we learn about the new hires, and we can also celebrate things together, all in one meeting, no matter the language you understand. Yeah, of course, another solution would be to speak English, but it has its downsides as well in a previously only German company. So that is basically why I got the idea to develop this tool. And the version that I built at the company was that this meeting is in Zoom. So there's 500 people in the same Zoom meeting. There's a big presentation from an office, and it's streamed to all the participants. So in this meeting, there was a lot of very sensitive topics discussed. We trusted Zoom, and it also has end-to-end encryption, but we did not want to send the audio data to any server. So this is, again, Whisper comes in. We have a big, very expensive computer in the office, which has a very expensive graphic card. And I just put Zoom on that PC. It joined the meeting, and on that PC was also Whisper AI running. So Whisper AI was basically also in the meeting, listening in to the German, generating the subtitles live, as you saw just now. The subtitles are combined with the video from the meeting in a little tool called OBS Studio, which is very useful for streaming, for example, also. In OBS Studio, I define something called a virtual camera, and I stream back the combination of the meeting with the subtitles that are generated live into the meeting, so that if people want to have subtitles, they can just watch the user which is logged in on the AI computer. So basically, Whisper is in the meeting as well, listening in and typing really fast. And people can just look at its camera to get the subtitles. Oh, this worked reasonably well. Since we are at EuroPython here, I'm going to zoom in on the Python part a bit and explain a little bit more about the challenges with the live transcription and translation. So the basic, it's a bit small. The basic structure of the program is that the Python records a little bit of audio, for example, 1 second. Maybe also adds it to make a longer piece of audio. Then gives it to Whisper, because Whisper can only transcribe pieces like files of audio. It can't really do live yet. So I'm kind of making it transcribe really fast and many different small things. It does its thing, it gives me the subtitles, and I show it. So no problem. But if you just implement it like this, without any thinking about asynchronicity, you realize that while Whisper is working, so the AI needs like 1-2 seconds to run, the audio code is not running. So I'm always losing as much sound as Whisper is taking time to translate. So of course, that's not good. So parallelism has to come in. What I really want is I want a thread or a piece of code to run in a loop and record 1 second of audio every second, really without a gap. And I want another piece of code to use Whisper, send it the audio that we have currently, and get the results back. Any time it's done, it immediately gets a new audio file to transcribe. And then on top, of course, I want to show the subtitles. I want to have them available not just while the AI is not thinking, but all the time. So 3 kind of separate parts of the code. Yeah, what I used is threading, the threads library from Python. I basically just started a thread for the listening code, which did this loop. I started a thread for the transcribing, and that's it. The rendering is a trick because it's actually it's shown via a browser. So I just use set timeout in JavaScript and ask every 500 milliseconds to get the new text. Quite easy. So this is the details of what I just said. The audio uses a temporary file, a WAV file. So actually the synchronization between these two loops is done via hard drive. So because operating systems are quite good at having multiple processes read the same file, and the WAV is really nice because you can add to the end, read from the beginning, delete from the beginning. It's super nice. It's basically like an array of audio on the hard drive. Yeah, so I put 1 second at the end of the file every second, and every few seconds, whenever Whisper was done. And then I told the Whisper thread, hey, there's a new piece of audio, go. And I did this via a queue, so I just added the audio file to the queue. And the Whisper thread reacts to this queue every time something is added, which is basically every time it's done. It runs, takes these 3 seconds, and outputs some text, hopefully. And then what you saw at the beginning is that some things, sometimes the text is gray because it's not really clear if that's really what was said. Sometimes it's black because I say, okay, I'm sure now. It's done for 2 reasons. I don't want to have this WAV file grow and grow and grow, because then the AI would have to think about more and more and more sound, and it would get slower and slower, and it would just not work at the end. And also, I want to display subtitles. I kind of need to say, okay, this subtitle is gone now, the next one is coming, things like that. So whenever it found a whole sentence, and very nicely, Whisper gives us these things, right? Remember, with the song, it was in 4 lines. So it says there's a phrase here, a phrase here, a phrase here. Whenever Whisper tells me a phrase has finished and a new phrase has started, I take the text and commit it. It tells me when this phrase was in the file, in the sound file, so I can just delete the time from the sound file. So it never really grows much. It grows a little bit, and then the sentence gets removed at the beginning. And then it grows again, the sentence gets removed. Where was I? And then I lost track. It removes the file from the beginning, and that's it. I'm not sure where I was going. But anyway, when the text is committed, it has another queue to send to the front end, basically, to add another line of text to the result array, so to say. And then the front end, like I said, polls every half second and gets the new text. There's an open source version of this. It's not quite exactly what is here, but has the backend part, basically, the parallel recording and transcribing. So that's the details of the program. Don't worry, there will be a link to the slides later. Now just some words about the Python details of threading and multiprocessing, just to compare these two, because there's 2 different things: threads, the thread library, and the multiprocessing library, and another one later. So threads, they have shared memory. So I started these 2 threads, but I can actually share objects between them, and I don't really have to think much about allocation of resources. Python does everything for me. They communicate. You can send data between each thread via a queue. So both threads are running asynchronously, and if I give the same queue reference to both threads, they can send each other messages through it. So this leads to asynchronous code, which you saw. However, threads actually cannot run in parallel, which might be surprising, but I'll explain it later. Threads are actually blocked by the GIL, the global interpreter lock, because that means in Python only one of the pieces of Python can run at the same time. However, when using an AI, we're calling CPython or something. I'm not actually sure how it works, but it's not Python that is running the TensorFlow model. that is not in Python, which is why at that moment the GLIL, the lock is gone, and the rest of the code can run again. So it is asynchronous, but not exactly parallel. But it works just well enough for my use case. And then the more complicated and stronger version would be processes, so multiprocessing. When you use multiprocessing in Python, you actually start whole Python instances. So you have 2 Pythons running. They are completely separate, which makes it quite a lot more difficult to write the code even, because you have to think about whether this code has now been spawned in a process or whether it is the main code, and so on. They also communicate via queue. The queues are not the same queues. That's why, yes, you can see the different colors. This kind of queue that you need for multiprocessing actually pickles the data. So I think it has to be serializable or something. I'm not exactly sure what pickling means because I'm not actually a Python expert, sorry to disappoint. But it is much more strict on what data you can send through the queue. The other queue is very easy. You can send references and things like that. There's also something called pipe, which is just connecting 2 processes. A queue can be read by multiple consumers and producers. So a queue is really general, but also makes the code a bit harder. Pipes are just one way in, one way out. And they are also very strict. And the main positive part of using processes, of course, is that it actually uses all your cores if you want. You can, if you spawn 8 processes, you can use all your 8 CPU cores. But note, so in my example with recording audio and transcribing with Whisper, I don't care about the CPU. I mean, the audio maybe uses the CPU, but Whisper does not. Whisper runs on the GPU. So I don't need multiprocessing. I actually did, the latest version I have is with multiprocessing, but the speed is exactly the same. It just is a little bit more fancy and takes longer to stop. So, but since that is the case, since actually I don't need real multiprocessing in Python, in the very newest version, I used async await, which isn't parallel at all. It is a single event loop, single threaded. You just have to write your code in a way that it never blocks itself. And it's fine because you can wait for the AI, and your Python code runs, keeps running. And so I can just use that. It makes coding easier because you don't really need a queue. You can just use in-memory variables if you're lazy, like me. And if you just use one file, it's super easy to read, as long as it's not too much code. And it just makes everything easy enough. Also, it works well with JavaScript and being a server. So it's actually an API for what I showed at the beginning is an API for the AI, which leads me to my next topic. What I presented now was running a Whisper AI on your computer, which is very nice. It can be very fast, depending if you just buy a nice GPU. The main good thing about it is probably the privacy and data safety. Your data does not leave your room. You can just do it at home. But the downside, of course, is it's quite a heavy thing, you know, the computer. I don't have it here. Maybe you noticed I didn't bring my gaming PC with me. So instead, the new version I wrote, which is on my GitHub and link in the end, is actually a server version of this. So what I showed you at the beginning is running right now in the cloud, which is actually not AWS or Google or whatever. I use Lambda Labs, which is quite a nice company. There you can rent really nice GPUs, really fast ones, for not too much money. So in AWS, if you use the cheapest GPU, it works. It has enough RAM, but it is so slow. It is basically unusable, same tool. If you just use it on Lambda Labs, I use the A10. It's kind of the weakest one, which I always have available. You could also use the H100, the best GPU in the world. You can just get it with a click for €2 per hour, which is quite nice. And this is the current version of my code, which runs quite well on the cloud. Yeah, so for the future, my idea or my dream is to have one of these tools, or maybe something that is not quite so big, to be able to go to any country, and I just have internet access. I can put it on and understand everybody around me what they are saying. if you have one of these things, talk to me. I want to try it out. Yeah, and that's it.
Thank you very much for this very inspiring talk. We do have time for some questions. If somebody has a question about this, then please step to the microphone.
Hi, loved your speech. You tested out like a few major languages, but if you would like try some more niche languages, not like Japanese, Chinese, not Lithuanian, or something, I don't know, from a small country, would it work?
Who in the room is from a very small country? Can we have a hand sign, please?
Yes, I tried Lithuanian. It works okay. Lithuanian is not great because there's not much training data. I have a Lithuanian friend. They were not happy. But yeah, if someone wants to ask the next question in an interesting language, I would be happy to.
Can you please, for this question, come here so that your microphone will work? Or
I think this will do, no?
Try.
Pokus číslo 1, zkouška mikrofonu. Bude to fungovat, nebo ne? Víc? Tak já nevím. Vítám vás na konferenci EuroPython 2023. Tahle přednáška je docela dobrá, výborná, užívám si to, děkuji.
So I think it can't hear you.
Nic moc.
I'm not sure what he said. Was that half right at least? No, it can't hear you. The microphone is over here, so it can only hear me. But yes, please, go ahead.
okay, let's give this another try.
Is it this one?
No,
Tak ještě jednou, pokus číslo 2, zkouška mikrofonu. Poprvé to moc nefungovalo, tak snad po druhý to bude lepší. No. Well, one more time.
Yeah, one more time. We have time, so let's try this once more.
Yeah, in the end it got something. Hopefully it will be better after the second one.
yeah.
That's what I think.
Of course, also silences confuse it a bit, and when you switch languages around, it's not that easy. But the longer you talk, the easier it gets. And there are a few sentences that you said, I think. Yes.
So another question, please.
Yes, I also took this a look on this Whisper AI, and there are these smaller models. Are they able to run on a normal laptop, or is it simply impossible because they are too small? And
Whisper can run on CPU. And it can, even if you have a lot of RAM, you can use the big models, but it is really slow. It needs a lot of. It actually needs a fast GPU as well as kind of some space. It needs the speed actually a little more than the space. If you can wait, then it's okay. If you have RAM and you can just use CPU, it's fine. But I recommend any GPU, especially gaming GPUs, because they are faster. The professional ones are not super fast sometimes.
Okay, the next question, please.
Yes. You mentioned that the AI outputs these phrases. Is it also possible to classify which person is speaking the phrase?
The AI cannot do it.
Okay.
So you would have to do some kind of voice recognition. Or I'm not sure. It's a different problem.
Thank you.
It's quite interesting too.
Okay, the next question, please.
Hello. Yeah, so there are some alternative implementations of Whisper. There is Whisper CPP, Faster Whisper, Whisper X. Did you try those? And
the example at the beginning is not Whisper, it's Whisper JAX.
Oh, it's yet another one.
I didn't tell you because I don't really know what JAX means. But it is a faster implementation, and it needs a little bit of more installation at the beginning, but kind of works the same.
Thanks.
Yeah, and really fast.
Thanks, I will try.
Yeah, go ahead. Whisper JAX, JAX, is good.
All right. You were threading the audios, and then you were joining and then sending to Whisper. Did you have any troubles doing that? It was straightforward, any issue?
Yeah, it's quite annoying sometimes. Handling audio. So in this last version, I'm handling audio from the browser. So the browser sends sometimes OGG and sometimes not, and sometimes it compresses it. It's there's some fiddly bits. But overall, especially when you're not using the browser and sending the sound over the internet, but when you're just using the microphone input into Python directly, that wasn't that bad.
And regarding noise, did you also manage to solve noise or ambient sound around?
No, I didn't do that. I only used Whisper. I didn't really massage the sounds. Whisper is very good with some noise. But what's interesting is when there's applause, it always says thank you. Because of course, that's what people say.
Okay, thank you. Actually, that is a good last word to thank you again for your talk, because we are out of time. Let's have another round of applause for Mathias.
Thank you, thank you, thank you, thank you, thank you.
And we will take a 5-minute break.